Hey, 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 it's W5HRO on a Tuesday, April 1st. April Fools! But this is no fool. This is no Fool's Day. It just happens to be April Fools. Well, I decided instead of messing with my tripod, I'm gonna do this the old way. I want to make a quick video to give you a quick update because I kind of got I've been taking my sweet ass time on this. Apologize for the French, but I've been taking my sweet ass time, to put it bluntly. And I've been slowly thinking this thing over. I finally drew up the circuit and I ordered a whole bunch of miscellaneous parts to kind of get an idea of what I'm going to do. And I started putting, this may either be the actual board that I use in here, permanently, or it's just going to be a test board. I haven't decided yet. But I thought this will make it easy because all I have to do is, I want to make sure I don't zap that FET because it's not connected to anything yet. The pins are just floating on the bottom of that board. They're soldered, but they're not, there's nothing terminating them. So anyway, I'm just going to put a standoff on one corner, like on one of those screw holes there. And I'll just to kind of test it out. And, I've already put the 1 meg pot there. I just kind of loosely tightened it. I have to cut off the shaft. That's a Clarostat. These were the last really great potentiometers you could buy that would handle the wattage. These were 2-watt, pots. These are 1 megs. Now, like I said, before it's over, I may wind up with like a 100K pot. You never know. And I may have a big fixed resistor and a 100K pot. It just depends on how low the voltage needs to be. That negative voltage needs to come up more positive. What I mean is less negative to where the tube starts conducting the 1625. So basically, I have the circuit drawn up. Let me put this up here. I have it drawn up, and this is just the first preliminary kind of like, I drew up one that I kind of thought about it, asked a couple people what they thought, and I came up with this. So basically, this is what I'm going to start out with. Now, the supply that's in here, that transformer is here, and the capacitor, the actual can is actually hot. This thing is reversed. I've got the can isolated from ground, and I never did. My plan was that cap that's in there, you can see at the top of it right there. I was going to put one of those black cardboard tubes over it, like on the, remember the DX100s and those various transmitters that had the can was actually hot like this, negative, and you had to put they had to float it for some reason, and they had the cardboard tube thing over it. Well, that's kind of what I was eventually gonna put a tube over that, because if I don't mark it hot, dangerous, if I die and somebody ever got this thing, they may kill themselves, Although it's only like a couple 100 volts negative, it's not that bad. I think it's like an 80 milliamp or 100 milliamp transformer, maybe 100. I think it's like 80 or something. It's a very small transformer because I didn't need much for that 1625 controlled grid control, But when I did that years ago in San Jose, I left the center tap floating. I made a full weight bridge because it wasn't exactly a 200 volt transmitter. And to try to get the voltage up to its max, I had to do the capacitor input and use the full weight bridge. And I used a small choke, just a 3 Henry choke. And right now I got to add, what I'm going to do is I'm going to swap these wires. I'm going to put this one here. This one's going to come down to the board. I'm going to have a load on the output. But that's kind of what I was doing. This is just that FET. I hope these aren't Chinese fakes. They might be. I'm going to find out. I started on this the other day, but then I realized I didn't have the hardware. I didn't have any more TO220 package insulators and the screws to screw into this heatsink. And first of all, I don't know if this heatsink has enough surface area. What happens is, what may happen in the end is this may just wind up being a test board. And when I find out what all the values I need and what I need to make everything work exactly like I want it to, is I may just wind up, mounting the heatsink here on the chassis, or just mounting the TO220 package right here on the metal, on the chassis like I was going to, but I know this metal gets hot. So maybe if I put a well, the heat sink's going to superheat too, probably over time. But, you know, if I have to, I'll just mount it here, and I'll just put one of those terminal strips here, and I'll just solder the relays just like you do in an old-fashioned tube receiver or a tube project. I'll just have the receivers go, the parts going across terminal to terminal, and it'll be hardwired that way. In the end, if I don't use a board like this or this exact same board in the end, then that's what I'll do, is I'll just, I'll hardwire thing the old-fashioned way, and, then that'll be good. I'll just have the FET heat sink to the chassis, maybe on top of heat sink, to try to maybe help out a little better. Whether it will, I don't know. But the good thing is I still have the 12-volt power supply for the old relay, and I put plugs where the holes were with the rheostats, and I'm going to put those terminal strips right there. I'm going to put one there and one there. Whether I'll ever have anything hooked to this one, I don't know, but I'm going to fill up that hole. I'm going to put the terminal strip, and I'll have one here, and I'm going to connect that 12-volt cable. This is just a piece of coax that's handling that 12 volts, and I'll put a bypass pin to ground. Then I can just run another piece from here down to the board to control the relay. And what I've done is I have a single pole double throw. These are only like 250 volts AC at was it like 10 amps or 15 amps or whatever it was. I can't really see through my phone here. You probably have a clearer picture now. 10 amps maybe. But you think about it. Well, DC is going to be a lot lower. However, what's going to happen with only 200 volts DC? I mean, it's not, and the transformer's only 80 milliamps to 100 milliamps max. It's not this relay will more than likely live forever. The contacts will probably be fine. But this is one of those mini relays, so I thought that's how I'm, if I could put it all on a board like this, and who knows, maybe this heat sink won't get that hot. I think it's probably going to get too hot, but let's just see what happens. Let me build the circuit on this and, finish it up, just temporarily mount it in here, hook up the pot and the supply, and let's see what happens, right? It can't hurt. So basically, this is what I've done. It's just the 1 meg pots there. This is basically a P-channel FET. It's just a MOSFET. So basically, it's just a pass transistor. So the voltage, and like I said, I'm not sure this is going to make, I think the output on this supply that's in here, it's actually going to be a little less than 200 volts, but that's fine. That's fine. It doesn't take a full 200 volts to put the 1625 in the cutoff. And in the end, I'm going to probably tailor these values. This pot may wind up being really small, and I'll have a big resistor here to where I just get the window I need to do what I need to make this thing to do. So what are you doing, Max? He's over here. My radio buddy's down here, but he's wanting to go outside to see what's going on. But I've been taking him out, but I kind of have a little harness thing on him. I take him out in front because this dude's been hit by a car like 3 times. He's on his 9th life, and I said, nope, you're adopted. You're not going outside anymore. You're gonna become an inside cat no matter what. So that's why he's whining. He's gotten better now. Now, when he goes outside, he can't wait to get back in. So we almost got him his brain reprogrammed. So anyway, what I'm going to do is that relay's there. So normally, because it dawned on me when it's just in idle, I don't want the 1625 drawing current from that screen pin on the tube when there's no power on anything on the tube. And so I'm like, that might cause a problem. Maybe not. So what I'm doing is I'm adding a relay to make sure the grid of the 1625 is pulled down to where it's guaranteed to start off and cut off. Then when I transmit, it's going to ground the relay coil, and it goes up and it lets off that, and then this is what's going to come through. And see, that's a blocking diode. So when I'm just idling in the receive mode, this is going to block it from coming through. This will be higher here than it will be here. So that's what I'm doing, and I'm putting all the bypass caps. And this, I may wind up eliminating this diode, because the more I thought about this, the more I actually think if it was because of the high modulation peaks, it was more than likely the positive peak, and it was getting right down through this thing, going way down, and it might have been forcing the filament. It was pulling it down below the the cathode, even though the cathode was grounded, it was pulling it down too far because I had the center tap of that filament winding floating in the beginning. So I don't know. But at the same time, when I put that new other transformer in and had it all connected properly with the thing grounded, it was still, unless when I had that bigger transformer in there and I accidentally threw 5 some odd volts to it. It was only on for like maybe 5 seconds before I turned the power off immediately. Unless that 5 seconds might have damaged that tube. Maybe that's why that failed too after I'd done that. I don't know. But anyway, I'm going to just pretend that's not what the issue is. That's the smart way to go about this. So, but I may want, since this tube is essentially the same as this diode, and since I think it's probably more than likely the positive peak more than it is the negative peak, I'll probably start off not putting that diode in unless the problem still happens, then I'll add it. Because it's just, it's better, but it'd be better having the thing, if it is the negative peak, going down 0.7 volts, or I'd probably have 2 volts in series, so it'd be like, 0.14 volts. It'd be better having it only going down that far, because the voltage drop across the tube being a diode is going to be that drop's going to be a lot larger. So it'd be better to only have it go down like negative 1.4 volts just for the protection. But I'm going to try it without that first and see what happens. But this is essentially where the actual screen connection, circuit connection connects to the 4-400 screen and the OD3 regulators, which is here. It connects this basically. Just pretend that this circuit is replacing this whole part right here. That's basically what it's doing. So anyway, that's what I'm going to try. And like I said, I've just been taking my time. I've been buying a couple parts at a time, thinking about this thing as I go. And I went to build this up this weekend. I realized I didn't have the insulating washer and the screw to mount this on the heatsink. I've got the heatsink grease and the thing soldered down. And if I didn't fry the transistor doing that, then we'll see what happens but I just got them from Amazon. And this is funny because, where I live out here, we're not in the country, but we're out just far enough that Amazon's kind of a godsend. I mean, the Amazon trucks here, sometimes they're here like every day for 3 days in a row, but they're usually here at our house delivering something like every 2 or 3 days. So, I ordered that last night or this weekend when I realized I didn't have the washers and the screws, and here they are. So I'm going to put these in here in a minute, clean up some of that grease, and see if I can't start soldering like I don't know. I'm going to do a rough calculation. I put a 12K here to start with, but I thought, well, wait a minute. And I thought if it was going to act like also like a negative peak limiter, that should equal the screen impedance. And I was thinking it was 3, but when I calculated it, it was like around 16.5 or a little more K. So that should be like 17K, 16.5K minimum if you were going to do it that way. But basically, I'm going to have to select this resistor. I don't know. That's why I'm worried about the 1 meg pot being too coarse. I may have to fine tune this thing and have a resistor above it and below it and just find that window to where the pot makes just a minimal adjustment. So 1 meg may be way too coarse. That's what I got to see, because I just got to, since the cathode's grounded, then when this thing starts turning on, it'll still turn on slowly, but it's going to be, you get to a point where it's just going to be, boom, it's going to turn on full, and the current is going to mount to whatever the drop is across that resistor, basically. So anyway, you can see where I am on this. I'm not worried about getting on the air. I can wait. This transmitter works. If I just want to leave this tube out and go in there and power, I could have been on the air all weekend and last weekend, but this last week it actually got really hot outside. We had one day that was like 83 degrees. So I went out and I was doing yard work for 2-3 days in my spare time after my job upstairs that I told you I do during the week from remotely here from home on the laptop. So I just thought, cool, I'll just go out there and do yard work. So I did that, and I didn't focus on this, and I didn't do basically shit with it, right? Pardon my French. So anyway, Let's see, I guess that's all on this end. And oh, one more thing. Now look what I got. Now I did, like I said, I bought other boards, other sizes. I didn't know this came from the Antique Wireless Association. They were selling these on eBay dirt cheap. The guy had a couple less, so I bought one. I thought I saw that. So if I find that heatsink, this might be a better setup. I could just modify this board. I could put the diodes in there and I could replace that terminal strip and just make, but then I'm trying to put this in here and I'm like, you know what? This is going to be too close to the loading and it's too big. So nah, but it was cheap. So I grabbed it. That'll be a project for future use. I can cut the traces, add jumper wires. I can modify the circuit on this thing, which is what I'd have to do for this anyway. But I thought that'd be kind of cool. But now this is the other thing. Remember these old Johnson test point terminals, these skinny BNCs? It's too bad the guy only had 5 of the black ones left, and I got one nut. That's the thing. The guy doesn't have hardware, but I have a few of these nuts laying around, and I think I can go to the hardware store. I think there's probably something I can get that'll work on it just fine. And if so, then I'm good to go. But remember when I told you I need test points for the screen voltage on this thing, and I'd like to have one right at the grid of this tube so I could see what the voltage is, and then maybe a black one for ground. Well, these things are getting really scarce, these old Johnson test points. And you know why I like these? For one very simple reason. Your meter leads plug right into them. I mean, so think about it. I'm going to have one probably here or somewhere. Where am I going to put it? The screen's here, but I want it connected to the pin of the freaking tube is where I want it. I don't want it. I want to see what the screen voltage on the tube is. So I might drill a hole here and I'll probably have to put a small bypass. Oh, I don't want to put a bypass cap to ground because that's going to add capacitance to the thing. So maybe if I figure out a way to put it, since I have that strap across both screen pins, I can put it over here. I can put it right here. I can take out this screw right here. I can put it right there. Then I can put the black one for the negative meter lead, or I could make that for the grid, the 1625 grid connection. Let me think about that, but that's sort of the plan is, hey, because that way I can go in there, I can put it in the rack. I don't have to worry about trying to clip under stuff, and I just plug my meter in, and I can see exactly what's going on when I decide what the final values are going to be on this thing. So this thing should work fine. Now, the only thing I don't know is, were these Chinese counterfeit parts? I hope not. There's a lot of that going around, every now and then, so you got to be aware. If not, I can get them, but, I think they look like they're the real ones. So anyway, that's where I am on this. This is basically basically a supply pass transistor circuit with a diode block, so I can leave this tube and cut off when it's in idle, when I'm in receive mode, just to guarantee that there's not going to be an issue. Then when I transmit, this voltage is going to be where this thing starts to turn on, and I can vary that voltage and how much current it's basically all it's going to do is because what happens is the way this transmitter is with the 1625s and this dropping resistance. Now, by the way, when I said there was 3 200Ks, this one down here is smaller than that, because 3 200Ks would only be like 50 some odd K, and the voltmeter, when I put the ohm meter across these, it's to 28.3K, and that's what I originally calculated. I just forgot, this one's upside down. I can't see the stamp on it, but I know it's less than 200K. These two are 200K, so I'd forgotten about that. But anyway, what I was going to say was, when I load this transmitter up, I get the proper amount of cathode current, and I set the grid drive, this grid drive knob, to 12 mils of control grid current on the 4400. Then I back the loading knob down to where I got 30 mils of screen current. And when I do that, my screen voltage is right dead smack at like 500 volts plus or minus, 5, 6, 7, 8 volts, maybe 10 volts at the max. I think sometimes I saw it like maybe 508, 509, 510, depending on exactly if I bumped the load just a little bit, it would drop down or go up one way or the other. But it's basically the regulators, the OD3s, and the one Zener, that's actually a 100 volt Zener. My original schematic called for a 50, but I increased that to 100. So what I have is the screen will fully regulate, well, that voltage won't move, at 550 volts on the screen. But that's wrong. So when I adjust the screen, the loading for 30 mils, it drops down to right at, the 500 even. And that's exactly what you want. I don't want this thing regulating in max regulation, because when you modulate, it's going to be too hard to get the voltage to go down. And so the way I have it is this thing operates just below the regulation point. So when I modulate, these OD3s dim down really far, but they could go down just a little farther before they would completely extinguish. And I want to get them right. And that's sort of why I want this. This whole circuit, this whole 1625 is going to be a current bleed. It's going to bleed the excess current from the OD3s, so they'll dim down all the way like I want them to, and from the screen. Because what happens is, if I adjust the load for maximum screen current, I get, almost 70 mils. Well, that's too high for the tube. The tube can't handle that. The 4400 screen can't handle that. So I need to limit that current. And that's really the main reason for this clamp tube. So when I originally came up with this idea, before I thought about SSB, my idea was to use the 1625, because the T368 transmitter, the RF deck, and the 4400 used the equivalent tube, which was the military tube of the 807. For this exact same circuit, they did the same thing. It was just if you lost grid drive, the screen voltage would short to zero, and they had like some kind of a heater type controlled relay that would open. And see, I don't have that in there, so it was just blowing the fuse, and I didn't really like that at all. So, but the fuse would just pop when it would, instead of having that relay that would open, that would protect everything. So I thought I'm going to add that and this regulator string, just to kind of like, the whole idea was, the thing is, when people set up these tetrode AM transmitters, these RF decks, they never seem to get the screen modulation correct. And what happens is that they wind up, it just doesn't, they get a phase lag or something where the peak on the screen happens after the peak on the plates already occurred on the anode, on the supply, and it causes problems. It's never good when you do it that way. So my idea was to use the regulators and the 1625 in conjunction like this, to where I could these things would just be there to pad it, to keep the impedance more stable, where they would dim down, but they wouldn't be super stiff to where it would, to think what? Okay, I'm back. Sorry about that. I'm having to splice this to the video I was making. The XYL just came home and she pulled up in the driveway and she heard me out here talking. So she banged on the garage door, wanting to get in this way. And then she wound up going upstairs and said, when I told her I was making the video. So I had to go up there and tell her what was going on and stuff. So anyway, that's what happened. But anyway, to finish this video up, what I was saying was, the whole idea was, when, I'm operating this thing, Class C AM phone, right? Ultra mod setup. And the whole idea was, you have to improve the screen modulation on these setups. That's the main thing people never understood about a lot of these old, people would build homebrew RF decks, or even some of the commercial stuff. A lot of those transmitters, those decks, never would modulate the screen properly. You'd always have a phase lag or something, and this was my idea. My idea to use the regulators was to make the impedance way more stable on the tube, on the screen, to keep it a little stiffer, more stable, but it can't be stiff to where the voltage isn't going to drop way down all the the way when you modulate, right? Technically, it should go all the way down to 0, but you just want it going down far enough to where the OD3s, the regulators, dim down to the point just before they extinguish, and they're almost there now. So my whole thing is that I'm going to have this adjustable knob here, that I can actually, bleed current off those OD3s in the screen, the excess current. Because like I said, what happens is if I adjust the screen current for maximum current with the loading knob, I get almost 70 mils, and that's way too high. So I want to block that at like 50 or 55. I think the tube will handle 60. But when I set this thing at 30 mils in normal operation, it bounces up just a hair over 40, so probably limiting the screen current via this knob. I'll make it to where I thought, which way do I want to make it work? Do I want to make it work clockwise or counterclockwise? And the grid drive, here it is. The grid drive is right beside it, so the more I turn the knob, clockwise, the higher grid current is. So what I'll probably do is make this knob go the same direction, to where what I'll do is I'll back it counterclockwise to like limit the current to back it off. And that probably makes more sense, because I went back and forth on that. Which way do I want to wire up these terminals? And I'm like, I'll make it go the way I just said. So that's the plan, and I just been taking my sweet time on this. I'm not in any hurry. So that's kind of what the deal is. And I have other size heat sinks and other boards, and was trying to get an idea how I was going to do this. If this thing winds up working and this heat sink doesn't get too hot, I may just leave this thing in here. Who knows? But it's going to be RF bypassed everywhere and everything, and I'll probably have a shielded cable going from the board up here to this pot and everything, with probably maybe bypass caps and terminals on the pot too, because I use coax here on that supply. I might use a piece of coax to do the same thing, who knows? So we'll see, because I just have to tie one of these ends to ground, right? Oh, no, that has to go. No, I got to have all three. I could solder the resistor right here to ground or something. I could use this tab where I could go from here to here, or whatever side it's on, but I'll figure that out when the time comes. So anyway, that's all for now, and I'm not in any hurry to throw this thing back on the air. The band conditions this last weekend were pretty good, and I was tempted even the weekend before. I thought, you know what, it's not too bad. And last weekend, there was a lot of activity on 75 AM at night and in the morning. In the morning, it's been halfway decent. Looks like we were getting a halfway decent band opening, or some decent peaks, or some decent conditions for local stuff and for the far away stuff. But I'm lazy. I was doing stuff, and I just don't feel like throwing this thing back in the rack right now. I would rather just take my time. If I have to wait to get, to actually talk to somebody next winter, fine. That's fine. But anyway, like I said, this thing all works. I just want to finish up this screen control circuit for the 1625 for my clamp for the screen current, etc. So that's basically all I'm doing. I decided, let me finish this thing up now. I'm going to also have the terminals here. Oh, and I did get on the 1625 plate connection on the top of the chassis, where I've got that new 500 picofarad. I went ahead and I got another one. I'm going to do the same thing I did on the plate choke. I'm going to have a 500 puff on top, and then this 500 puff on the bottom. So I'm going to add the other one down here on the bottom too. So I got one just like I did on the other, and that'll give me the 1000 picofarads back on that bypass, which is, where is it? This one right here. This will become 1000, because there'll be one on top, one on the bottom of the chassis. So that's all for now, 73s. And like I said, my plan was to have this already done, and already have done another video of the shack and the rack showing you that it works and everything. But I got sidetracked with the good weather last week, and I just decided to take my time. I'm ordering one part at a time, and my plan is that when I find out what exactly this I'm going to load the output of this supply down and see how high the voltage is, and kind of get an idea. I'm going to put like a 5-volt Zener to regulate that supply, because I want a regulated voltage This, like say I got minus 200 volts. This may only be 180 volts or something before it's over. I don't know. So I got to figure out what it looks like when I load it down a little bit. Then I'll pick the right zener for it. So I'm going to I might just put the zener, that 5-volt zener, that 5-watt zener on this board, and then have the dropping resistor from there on over, you know. So that's all for now. I guess 73s, and hopefully the next video I'll have this thing, I'll have it all the stuff in there and working, and maybe I'll have the thing partly done or have it hooked up here, and I'll be playing around with the 1625, making the thing glow blue a little bit. I don't know, we'll figure it out. Hopefully the next video will be more advanced on this, and I'm sure I'll probably just hold off until I get this thing where I'm going to have it in the rack and then do another video. 73s, this is W5HRO.